let's get to it. Today we are going to talk about radian and degree measure. This should be like a, oh yeah, from algebra 2. Okay, so we are going to talk about measuring angles. Okay, you are very comfortable with degrees. By the end of this chapter, well, by the end of third quarter, you're going to be super comfortable with radians. Okay, so a radian is the measure of an angle that intercepts an arc that's equal in length to the radius. I'll let you go ahead and write that down, and then I really want you to also copy this down right here. Okay, so when we talk about 1 radian, we are talking about the radius being the same length as this arc that the angle is eating. Okay. Yeah. How often do we really say 1 radian? Okay, the radian measurements that you think of most often involve a pi, involve the number pi. Okay. So let's recall, and I'll wait till you finish writing. Okay, we're going to recall how to convert from degrees to radians, radians to degrees. Okay, knowing that 1 radian is the ratio, well, any radian is the ratio of arc length to radius. Okay, but we have 1 radian when that arc length equals the radius. If you had Miss Cronky last year, I know you like colored what 1 radian was, and she like hung them up in the hallway. Okay, yes, I remember that. Okay, I don't think Mr. Bodine did that, and I don't know about Ms. Thompson. All right, now let's talk about going from radians to degrees. Please tell me how many degrees are in this circle. How many degrees are in a circle? Okay, 360 degrees. Now, if a radian measure is, let's come back up here, is the ratio of arc length to radius. Okay, how do we measure this entire arc length, the entire circumference of the circle? How do you calculate the circumference of a circle? Pi times diameter, and diameter is the same as how many radii? So 2 pi r is our circumference. Oh, which means our angle, 360 degrees, is the same as 2 pi. So 360 degrees divided by 2 pi is the same thing as 1. Those equal the same. Can I reduce that? Okay, this is our magic ratio. 180 degrees over pi, or pi divided by 180 degrees. They're the same measurement. So writing them as a fraction is writing like the number 1, right? Like 12 inches over 1 foot, okay? They're the same measurement. So if we have some sort of degree measure, like 120 degrees, how do we get that into radian mode? Okay, just like in science, when we convert units, right? We're getting rid of degrees. So I want to multiply by a fraction where 180 degrees is in the denominator, which means what do we put in the numerator? Pi. And now we can multiply across and simplify. 120 over 180, what would that simplify to? So 120 degrees is the same thing as 2 pi over 3 radians. Okay, radian measure does not have any sort of symbol. So if you have an angle and there's no degree sign, then that means it's a radian. Okay. Now, what if we're going to go the other way? What if I have, well, I totally went backwards. This is degrees to radians. What if I want radians to degrees? What if we have like 7 pi over 9 and I want that to be a degree measure? What fraction are we going to multiply by? Yep, 180 over pi. We want the radian measure now to be in the denominator, okay? Not all the time will your radian measure have a pi, okay? But we want that radian measure to cancel out, so the radian has to go to the denominator. In this case, yes, there is a pi for them to cancel out, and we have 7 times 180 degrees divided by 9. Guess what? We can do this without a calculator. Are you ready? What's 180 divided by 9? What's 20 times 7? 140 degrees. Look at us. So we know that 7 pi over 9 is the same as 140 degrees. Okay, is that coming back to you from algebra 2? Yeah, it is. It will. Okay. Tomorrow I'm going to give you a lot of practice on converting from degrees to radians. Okay, you're going to be pros at it after tomorrow. Okay, basically what we need to do is if we have a radian measure, we're going to multiply by 180 over pi, so the radians cancel and we're left with degrees. If we have a degree measurement, we're going to multiply by pi over 180 so that the degrees cancel and we're left with the radian. Okay. All right. Let's talk about graphing angles in standard position. Okay, we are going to graph rotational angles. So when we graph in standard position, we are always going to put our initial sign on the positive x-axis. And then we will put the terminal sign in whichever quadrant it needs to be based on our rotation. Okay, so I'm always going to put a little arrow here to signify which way we're rotating. Okay, a positive angle is going to begin at the positive x-axis and rotate counterclockwise. Okay, It is possible for us to have a negative angle. In that case, we would rotate clockwise. Okay. Now, I will ask you to tell me which quadrant an angle is in. So let's remember what our quadrants are. So quadrant 1 is right here. Okay. We would begin at 0 degrees and quadrant 1 would end when we rotate up here to 90 degrees. Okay. Here would be quadrant 2. Quadrant 2 is between 90 and 180 degrees. We keep rotating. This is quadrant 3 to 270, and then quadrant 4, 270 to then 360. Okay. So if I ask you to graph an angle that's 172 degrees, you would know that that needs to go in the second quadrant. So probably pretty close to the 180 degree mark. Okay. So let's maybe practice a couple of those. Let's graph 120 degrees. Eric, what quadrant would that fall under or in? The second quadrant, okay? And probably closer to 90 than it would to 180. So here is 120 degrees. And notice how I drew my arc with an arrow so I know which way I rotated. Okay. Oh my, negative 750 degrees. So first of all, the negative means we're going to rotate which direction? Clockwise. But 750, that is way bigger than 360, isn't it? So that means we are rotating 360 degrees and we keep going. Okay, so help me out. I've rotated 360 degrees. How many degrees are left? What's 750 minus 360? 390. Oh my gosh, that means I have 360 more and then 30 degrees more. Okay, so this looks the same as negative 30 degrees, but we wrap around twice and then keep going that negative 30 degrees. Okay. Now, I feel that these reminders from Algebra 2, you're going to be pretty comfortable with anything that's in degrees. The radian measurements are going to be the ones that are going to maybe push you a little bit. But let me tell you, after this year, it's like radian measurements all the way. Okay. In calculus, we work with only radians. Okay. So we're going to get pretty comfortable with radians in this class. So let's talk about what our coordinate plane would look like in terms of radians. We still have quadrant 1, 2, 3, 4. Okay. But if we talk about the measurements, we're going to start at 0 radians. Okay. What did we say 180 degrees was the same as? What? Pi. All right. So this measurement right here is pi, which means this measure at 90 degrees would be what? Half of it. Write that in half. Okay. We already said that 360 degrees was the same as 2 pi. So all the way around is 2 pi. Okay. So pi to 2 pi, right in the middle, this rotation is 3 pi over 2. Okay. You're going to have to work with fractions and that's just going to be okay. All right. Notice how all of these are in terms of pi. So if you have like a 7 pi over 5, you need to figure out where does 7/5 fit in terms of 0, 1/2, 1, 1.5, 2. Okay. So let's go ahead and practice. Let's talk about 5 pi over 2. We are going to graph 5 pi over 2. Okay. So the first thing, like that kind of seems like a big number, right? Is 5 halves bigger or smaller than 2? It's bigger than 2, which means 5 halves pi is bigger than 2 pi. So we're going to rotate all the way around once. Now, if we rotated 2 pi, how much is left? Well, if we think about 5 halves and we subtract 2, we have 1/2 left. So 1/2 pi is just to that 90-degree mark. Okay, so there's our angle. It looks like pi over 2, except we rotate an extra 2 pi. Okay, and we'll talk about what's special about that relationship here in about 5 minutes. Okay. All right, let's talk about one more angle to graph, 4 pi over 3. Four-thirds pi. Okay. Well, I'm pretty sure 4/3 is smaller than 2. Do you agree? But is 4/3 bigger than 1? So we know for sure this is going to be bigger than 1 pi. Okay, so 4/3, where does it fall in terms of like 1, 1.5, 2? 1 and a little bit, but not quite 1.5, right? So 1 rotation and a little bit, but not quite to 1.5 is going to be our 4/3 pi. Okay. We'll get a little bit more exact. The 30, 60, and 45-degree angles are going to be very important to us. Okay, and we'll work with those a little bit tomorrow. But by the time we get to Friday, we'll have a much clearer picture of where some of these angles are going to fall. Okay, but for today's homework, just do your best. It might not be super exact, but as long as you get it in the right quadrant, I'm going to be happy. Okay, so just make sure we're getting it in the right quadrant. All right, it's too quiet in here. I need you to take 60 seconds and at your pod, come up with a definition for 2 angles that are complementary and 2 angles that are supplementary. Ready, set, go. Ooh, that was like way shorter than 60 seconds. Nicolette, 2 angles are complementary if okay. And since we know radian measures also, 90 degrees is the same thing as pi over 2. So if you have a radian measure, there are going to be 2 angles that add up to pi over 2. Okay. Kristen, what about supplementary angles? Okay. So 2 angles that add to 180 degrees, or if we're in radians, pi radians. Okay. I am fully confident that I could give you an angle like 40 degrees and you could tell me its supplement and its complement. Let's do that right now. 40 degrees. Its complement would be what, Grayson? Good. And 40 degrees, its supplement would be what, Luke? Okay. We know that they have to add up to be 180. We know that complementary angles have to add up to be 90 degrees. Now, it's not going to be quite as smooth with radians. We're going to have to think a little bit harder, but that's okay. We can do it. We're going to take 5 pi over 12. And I want to find first its complement. okay? So we said two angles are complementary if they add up to be 90 degrees. Well, we're in radians, so we need to work with pi. Okay, excuse me, pi over 2. So pi over 2 should be the sum of 5 pi over 12 in its complement. So we need to take pi over 2 and subtract 5 pi over 12 so we can figure out what its complement is. Oh my gosh, we have to subtract fractions. Can we do it? Yes. How do we subtract fractions? We need common denominators. So I'm just going to change this to be 6 pi over 12. And now we can easily see that our complement is 1 pi over 12. Are you okay with that? Okay. Now our supplement. That two angles are supplementary if they add up to be 180 degrees or pi. So 5 pi over 12 plus what equals pi? Well, we're going to have to figure that out by taking pi minus 5 pi over 12. Okay. Now, some of you may be able to look at this and not actually write out the common denominator. You can think about it in your head. We know that this is 12 pi over 12. Right, that one's a little easier. So 7 pi over 12 is our supplement. Okay. Now, you guys probably remembered that those two words pretty quickly. Our next word is coterminal angles. This might be one that's a little bit more difficult to find back there in your files. Okay. I know that you talked about it last year in Algebra 2, but let's just brainstorm at your pod what coterminal angles mean. I'll give you 60 seconds to just brainstorm. All right. I hear some groups talking a lot and I hear some groups talking a little. Who thinks they really remember what they are? Okay, Grayson. Yeah.
I don't know if I can explain it. I just know what it is.
What are they? What?
Two angles are coterminal when they have the same initial sides.
Okay, so do you see how it says coterminal? Me and Miss Herbson are co-sponsors of NHS. We share the title of sponsor. Coterminal angles share a terminal side and an initial side too. Okay. Grayson, with that lovely definition you gave us in your own words, could you give me an example of two angles that are coterminal?
Yeah. 7 pi.
Pi over 3 and 7 pi over 3. Notice how we begin and end at the same place. One just gets to rotate a little bit more than the other. Okay. So what happens is basically we take our terminal side and we can keep rotating 360 degrees in the positive direction or in the negative direction. And we can get an infinite number of coterminal angles. Now, we're not going to get crazy. I'm only going to ask you for like a positive and a negative coterminal angle. Don't be obnoxious, please, Grace and Truex. Let's talk about 70 degrees. Okay. First of all, which quadrant does 70 degrees lie in? First quadrant. He was ready to answer. Didn't know I was gonna call. Okay, so 70 degrees lies in the first quadrant. Okay. Now, one coterminal angle would be if we took 70 degrees and we kept rotating in the positive direction. An entire rotation is how much? Oh, and 360. So if we take 70 and we add 360, we would get an angle measure of yeah. There is a coterminal angle. And we could add another 360 degrees and we could have 790 degrees if we wanted to. And we could be obnoxious and we could keep adding 360, 360, 360 and get an infinite number of coterminal angles. We're not going to be obnoxious though, right? Yeah. Okay. I have no faith in that. All right. Now we could even go the other way. We could take 70 degrees and we could rotate in the negative direction. So I could take 70 degrees and we could go the negative direction 360 to get negative 290 degrees, which would have the same initial, the same terminal, but we would be rotating in that negative direction. Okay. Notice how all three of these angles have the same initial and terminal side. They all just have different amounts or directions of rotation. Okay. What's going to be really cool about this is next week we're going to get into like the sine, cosine, tangent of these angles, and they're all going to be the same because they're all coterminal. Okay, that's where this is going. Okay, now we have to talk about radians. Go ahead and plot where you think 3 pi over 4 should be on your coordinate plane. Plot the angle 3 pi over 4. Check in with your neighbor to see how they do it. Are there degrees or radians? Do you see a degree sign? Then they're radians. They don't need it. So, yeah, so you have measures. Bella, what quadrant are we in? We're in the second one, and it's actually exactly halfway through the second. Okay, so there's 3 pi over 4. Now, if we want a supplementary, no, we're not doing supplementary. If we want a coterminal angle, then we want to just rotate an entire rotation around, which in radians is 2 pi. So we are going to add 2 pi. No, you're talking to yourself. Yeah. Okay. So we're going to take our angle and we're going to add 2 pi. Okay. Now I'm going to make common denominators in my head because I feel like we're mature enough to be able to do that. 2 pi is 8 pi over 4. So 11 pi over 4 is a coterminal angle. We rotate around one time and then 3 pi over 4 more. Now let's say we want to go the other way. If we take 3 pi over 4 and we go backwards one rotation, we would subtract 2 pi, aka 8 pi over 4. So we have negative 5 pi over 4. Now I believe your book is going to ask you to give one positive and one negative coterminal angle. Well, what if your original angle is 500 degrees? If you subtract 360, is that going to be enough to get a negative coterminal angle? No. They might give you an angle that's so big, either in the positive or negative direction, you might have to rotate a couple times to get there. Okay, so if they say one positive, one negative, that may take you a little bit of work. Now, remember, just because there's a pi doesn't mean it's a radian measure. Or just because there's a lack of a pi doesn't mean it's not a radian. Okay? How do we know the difference between degrees and radians? A degree has a degree symbol. A radian does not. Okay? Okay. Okay, the arc length is a piece of the circumference. Okay, we already kind of talked about arc length like way at the beginning, right? When we defined a radian, we said a radian was the arc length over radius. Okay, so at the beginning of our time today, which I know we've covered a lot, right? At the beginning of our time today, we talked about how a radian measure was the ratio of the arc length over the radius. Okay, and we had that picture of like the pi. Well, if I'm looking for the arc length, I can take this fraction and multiply the denominator over. So arc length is actually the radius times our angle. But this angle came from our radian measure definition. So this angle has to be in radians. Okay, so we are finding arc length right here, what I'm highlighting in yellow, by taking radius times our angle, but the angle has to be in radians. Okay, so that's the formula that you're going to need. FYI, it's going to be colder tomorrow morning. So if you were cold walking into school today, maybe you want to dress a little warmer tomorrow. Okay. All right, here's our example. We're going to find the length of the arc cut off by a central angle of 30 degrees in a circle with diameter of 3.6 inches. Write down the information. Write down angle of 30 degrees, diameter of 3.6 inches at the very least. they had open swim, like it was free.
Yeah. And people just can't start.
They had like community swim days where even if you weren't a member, you could come and swim. So that's why I was.
Were you there?
I did not go to swim, no. I knew it'd be busy, so I didn't want to. All right, so we know that arc length is our radius times our angle. Okay, so first of all, I have the diameter, not the radius, okay? So if our diameter is 3.6 inches, Morgan, what would our radius be? If our diameter is 3.6, how do we get our radius? So the diameter is this, divided by 2. So 3.6 divided by 2 is 1.8. So our radius is 1.8 inches. Can I use 30 degrees in the formula? No. No, because our theta needs to be in radians. This comes from the radian definition. We have to go in radians. So 30 degrees, whoops, 30 degrees, we're going to convert to radians. So remember, pi and 180 degrees are the same. If I already have degrees, and we want degrees downstairs so that they cancel. $30 over 180 would reduce down to pi over 6. Eventually, you're just going to know that 30 degrees is pi over 6, but there's why. Okay, so now our arc length is our radius 1.8 times our angle in radian measure, pi over 6. Okay, guess what? I will allow you to use your calculator on this. Okay, Grayson, you found the pi button. Could you please take 1.8 times pi divided by 6? And we are in inches, okay? We've basically measured an arc, right? A piece of the circle, okay? So we can't do that with a ruler, right? But if we like had a flexible ruler, that's how long that would be, okay? Okay, the very last thing we're going to do, a sector of a circle is basically like a piece of pizza. Are you just like waiting to get out of here? What time is it? Okay, the area of a sector. We're talking about the area of a piece of pizza is 1/2 pi r squared, where 1/2 theta r squared, where once again, theta has to be in radians. I am fairly confident that in algebra 2, you worked with both of these formulas. So okay, so if I ask you, here's your last example, and then we're done, Eric. Okay. Looking at your one. Okay, we have an angle of 15 degrees and an area of pi over 3 centimeters squared. So our area formula is 1/2 theta r squared. Remember, theta has to be in radians, okay? And this time we're actually looking for the radius. So we know that our area is pi over 3. We are looking for our radius, but I can't use 15 degrees. I need to use a radian measure. So please go ahead and convert that degree for me. We multiply by pi over 180 and we reduce 15 over 180. What is that fraction? Pi over 12. Whoa, 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 whoa. Okay. So we have pi over 3 equals pi over 24 r squared. If we divide both sides by pi over 24, that is the same thing as multiplying by 24 over pi. That means r squared is 8. So r is not plus or minus square root of 8 because our radius can't be negative. But if you have a radical, I absolutely expect you to reduce your radical. You will get taken off if you don't reduce a radical, and that will become very important, especially tomorrow when we work with our right triangle trig, SOHCAHTOA, and using the Pythagorean theorem and all of that. Okay, so we have a lot of little itty bitty things that we talked about today. Okay, your homework you can find on your gold sheet. The page will be posted, and make sure you use Calc Chat, also posted in Google Classroom, to check your answers for the odd ones. Okay,